Happy day, students. So in our last class we discussed about this setup in which we took that the distance between two sources is a lot less than the distance between sources on the screen. Okay, but now I am going to tell you another case in which this small d is actually very large as compared to the wavelength. Okay, this d is very large as compared to small lambda. Okay, so let's go back to what we did in the previous case. I told you this path difference here is sin theta equal to lambda x by d. Okay, this sin theta is delta x by d, not lambda x, delta x by d. And normally this delta x, what we used to take, if suppose we are going to find first maxima, this delta x is lambda. If it is second maxima, it's 2 lambda. Or if we are going for some minima, then it is whole number multiple of lambda by 2. So if I say delta x right now is n lambda by d, and already you said that d is very large as compared to lambda, that means this factor is very, very small. So when this factor becomes very, very small, this theta tends to 0. And when this theta tends to 0, in that case I can write sin theta equal to theta equal to tan theta. In that case what we can do? We know that sin theta is here n lambda by d. And tan theta what we found? It was y by d. So in this case, the position of maxima or minima or whatever you are searching, we can find with y equal to n lambda d by d. This is for maximum, okay? For any maxima. Suppose first maxima, then we are going to put n equal to 1. If it is second maxima, we are going to put it 2. Third maxima, we are going to put 3. And if suppose minima we are finding. So minima's case, what will be the difference? Here, it will become n lambda by 2. Okay? This will become n lambda by 2. Or you can write 2n plus 1 lambda by 2. That's your wish. Because for minima we write delta x as 2n plus 1 lambda by 2. Correct or not? So, if I am going to make for maxima and minima one sustained interference, if I want to show on the screen, how will that be? Let's see. Okay. So here, because this is at the middle, we said that this is 0 as maximum or central maximum. Okay. After that, what will happen? After that will come first maximum. Then you can say second maximum. Now, the question is that we found right now, what we did is, we said that sin theta, which is delta x by d, is equal to tan theta, which is y by d. Again, in which case this is? When small d is a lot bigger than lambda. Okay? So delta x by d equal to y by d. So y is equal to delta x capital D by d. So if I am going to find the first position of first maxima, because this is y, okay? So y will be first maxima, that means delta x will become lambda. So y1 lambda d by d. Okay, then y2, that means second maxima. Second maxima in this case, delta x will become 2 lambda. So this becomes 2 lambda d by d. And for third maxima, this delta x will become 3 lambda. So in that case, y3 will be 3 lambda d by d. So you are getting this position. This is lambda d by d. This is 2 lambda d by d. Okay. Same way, if I am going to find minima. Now for minima, what should be the path difference? Lambda by 2. Delta x value should be lambda by 2. So lambda by 2 d by d. So this value here will come as lambda by 2 d by d. Then second minima, which will be here. So what will be the path difference for the second one? For second one, what will be writing over here? 3 by 2 lambda. How 3 by 2 lambda? Because we know that in case of minima, delta x is 2n plus 1 lambda by 2. Okay, and we are going for second minima. In second minima's case, n is kept 1. Okay, so keep 1, 2 into 1 plus 1, that is 3 lambda by 2. Okay, for first minima, what I kept as n? 0. For first minima, n I took 0. For second minima, I am going to take n as 1. So what is coming? 3 lambda by 2. So what will be this gap here from the central maximum? 3 by 2 lambda capital D by small d. Okay, remember when to use this formula? When d is a lot greater than lambda. And believe me, 95% of the questions will be solving on this formula. Okay, so now once we got that first minima's position, second maxima's position, third maxima's position. Okay, the difference between first maxima and second maxima, third maxima and second maxima, or first maxima and zeroth maxima is called fringe width. Okay, what is fringe width? And we represent that with beta. What is fringe width? Gap between two consecutive maximas or minimas. Okay, that means if I am going to find here, or rather we already have the value of first maxima and second maxima. So what is the gap? That is called beta. Okay, so here I am writing y2 minus y1. So what is y2? Y2 is 2 lambda capital D by small d. Okay, what is y1? Minus lambda d by small d. We have written it over here. This is y1, this is y2. Okay, so this minus this. What's coming? Lambda d by d. This is fringe width. Okay, are we going to get the same value for minima also? Let's check. So, second minima and first minima. So, second minima is this one. And what is this gap? 3 by 2 lambda d by d. First minima, what it is? Lambda by 2 d by d. Let's find out. Beta equal to second minima's position, which is 3 by 2 lambda d by d minus first minima, which is lambda by 2 d by d. Check what's coming over here. This is 3 by 2, this is 1 by 2. Answer is again lambda d by d. So, the gap between two consecutive maxima or minima is called fringe width and its value is lambda d by d. Okay? Now, let us solve few questions based on whatever we have studied in last class and today's class. Let's see the first question I am giving. So, in this question, let's assume the two sources are like this. This is S1 and this is S2. Okay. And this one is equal to 2 lambda. And here is the screen. Okay. Assume that this is 1 meter. Okay, now we want to find the positions of first maximum. Okay, position of first maximum. So first thing is, when we are starting to solve it, we will find out that what is happening over here. So if you take this point, if I say this is P point, what is the path difference at point P? Path difference will be S1P minus S2. So what is the path difference? 2 lambda. 2 lambda corresponds to maximum or minimum? Maximum. So here is second maximum. What are we finding? Position of first maximum. Where will be first maxima? Maybe somewhere here. Now what to do? If this point we say is Q, then we have to join S2 with Q and S1 with Q. Okay. Now can we say that this gap between the two sources, which is 2 lambda, is a lot lesser than this 1 meter? Can we say that? Yes. Because lambda normally is taken in angstrom. Lambda will be in angstrom. And this is 1 meter. Okay. So this is very less. So what we can say? We can say that S2Q and S1Q are almost parallel. Okay, S1Q and S2Q are parallel. So to find the path difference, what you will do? Drop a perpendicular like this. Correct? We drop the perpendicular like this. Let's say this is M. Now this will be the path difference between S1Q and S2Q is actually equal to S1M. This is the path difference. Okay? And see this right angle triangle then. If this is 2 lambda, then this delta x will become 2 lambda cos theta. Okay? This became 2 lambda cos theta. Now, what are we searching at? Q, first maximum. So for first maximum, what should be the path difference? Lambda. For second maximum, path difference is 2 lambda. For first maximum, path difference is lambda. Let's put lambda over here. So lambda equal to 2 lambda cos theta. Lambda gets cancelled. Cos theta is equal to 1 by 2. That means theta equal to 60 degrees. Okay. But now what we are finding? We are finding this value of y. So what to do then? To do this, we are joining this middle point also from that point Q. Join this point here. Okay. Now this one, and this one. All three are parallel. Okay. And we already have assumed this is theta. From where we got this relation delta x equal to 2 lambda cos theta. This is theta. This is theta. So this is also theta. Okay. So in this triangle you see, the dotted line triangle. In this triangle, I can say tan theta equal to this y by this 1 meter or d. Tan theta equal to y by d. Okay, so we do it here. Y by d, which is 1 meter. Now theta is what? 60 degrees. Put tan 60 over here. Tan 60 value root 3. So we are getting y equal to root 3. Okay. Same way. Here I can find the position of first minimum also. If suppose first minimum we are finding, so what will be the change in that? The change will come only here. It will be the change. Here there is no change. We will be taking this as delta x equal to 2 lambda. In that case this will be theta 1, this will be theta 1, this will be theta 1. If this is first minimum. Now I am taking this as first minimum position. Okay. So angle has changed because first maxima we got above first minimum. First minimum was here. Okay. So angles will be different. But the procedure is same. Delta x again will be 2 lambda cos theta 1. And since you are finding first minimum, this delta x will be writing as lambda by 2. Okay. For first minima, the path difference should be lambda by 2. How this first minima is? See. If suppose I take this is second maximum, okay, then here will be second minimum, then first maximum, then first minimum. Okay, so what are we finding? We are finding out from here which is the first minimum. So if we are going for this minimum, this is second minimum. Okay, on this side also, after second maximum, what will come? Second minimum. Then comes first maximum. Then comes first minimum. Okay. So what are we trying to find? Second minimum or first minimum? That should be clear to you. If you are finding second minimum, then path difference should be 3 by 2 lambda by d. 3 by 2 lambda d by d. Okay. Or path difference should be 3 by 2 lambda. Okay. Whereas for first minimum, path difference should be lambda by 2. That should be very clear. So what are we doing here? We are finding first minimum. So for first minimum, what is the path difference? Lambda by 2. Put it over lambda by 2. This is 2 lambda cos theta 1. Lambda gets cancelled. What we are getting now? 1 by 4 equal to cos theta 1. Okay. Then the same way, other one, what is that? Tan theta. In this triangle also, tan theta will be y by 1. So what will be tan theta? Cos theta value is 1 by 4. Then tan theta value will be root over 4 square minus 1 square by 1. Is it correct? Yeah, this is root 15. How we are saying, you can check it on this one. If this is theta 1, it's coming as 1 by 4, that means this is 1 and this is 4. So what will be this? Root over 4 square minus 1 square, that means root 15. So root 15 by 1 will be tan theta value. Put it over here, so root 15. So y value is coming root 15. Did you understand? First maxima was coming where? A root 3. First minima is coming where? Root 15. Okay. Same way, suppose second minima you are finding, then what will be the position? The second minima, this difference should be 3 lambda by 2. Then this will come 3 by 4. Cos theta will come 3 by 4. And 3 by 4 cos theta means 53 degrees. So then we will keep 53 degrees over here. Okay. Then it will become 53 means 4 by 3 will come. Okay, let's check. Let's do it, then it will be clear to you. Now I am going to find the position of second minimum. Okay. Second minimum position. So at second minimum, what will be delta x? It will be 3 lambda by 2. Okay. That's equal to 2 lambda cos theta 2. Lambda gets cancelled with 3 by 4. Okay. This is not 53 degrees. So this is 3 by 4. So tan theta will be what? Here, this is 3 and this is 4. Okay. So what will be this then? Root over 4 square minus 3 square. That means 16 minus 9. 16 minus 9 means 7. So root 7. This is root 7, this is 3. This will become root 7 by 2. So tan theta we will be writing again what? Y by d, which is 1. So this is root 7 by 3. So y value is coming root 7 by 3. So second minima, this second minima is at root 7 by 3. First maxima is at root 3. And this first minima is at position root 15. Again, root 7 by 3, second minima, first maximum, root 3, and first minimum, root 15. Is that okay? So that's how we can find the positions in this kind of problems. Okay. And remember, in this case also, this is not very less than lambda. It's comparable to lambda. That's why we did not take sin theta equal to tan theta. Okay. That's not applicable in this. Let's solve few more problems. Now suppose that there are two sources and this is the screen. Screen we are taking in a circular form. And on the diameter, two sources are kept. And the difference between the two, let's say, is 4 lambda. So how many maximas are possible on this circular screen we have to find? Okay, number of maxima on circular screen. Okay, so here you can see that the gap between them is 4 lambda. So I can expect here to be 4th maximum. Here also there will be 4th maximum. Okay, what will be here? Here and here. Now you can see that at this point, path difference is 0. If path difference is 0, that means what is going to happen? 0 is max. Here also and here also. So 4th here, then 3rd will be here, then 2nd will be here, then 1st will be here, then 0. Again, 3rd will be here, 2nd will be here, 1st will be here, then 0. Here also. 3, 2, 1. Here also. 1, 2, 3. So how many maximas are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 maximas. Then how many minimas? Between every two maximas there will be minima. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and so here are 16 maxima and 16 minima. But now suppose I am going to change this. I am going to write this as 3.2 lambda. If it's 3.2 lambda, then what's going to happen? Circular screen, same question. No change in the question. Only thing is the gap between the two sources is 3.2 lambda. So what will be the change? How many will be number of maximas and how many will be number of minimas? Are we going to get maxima over here this time? The path difference is 3.2 lambda. Answer is no. Answer is no. Are we going to get here 0th maximum? Here and here? Yes. Here is 0th maximum. Here is 0th maximum. Maximum path difference is 3.2 lambda. Okay. So 3.2 lambda is maximum. So will it be 3 lambda at any point? Because here the path difference is 0 and here the path difference is 3.2 lambda. So in between it will be 3 lambda somewhere. That is yes. So here will be 3.23 lambda. So we can say here is third maximum. Then here somewhere will be second maximum. Here somewhere will be first maximum. There is no doubt about that. And here but delta S is 3.2 lambda. Same way here again, third maximum, second maximum, first maximum. Here also third, second, first. Here also third, second, first. So how many maximas are there? You can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Maximas 15. How many minimas? How many minimas are there? 1, 2, 3, 4, 5, 6. In between any? No. It's no, because here path difference we have taken is 3 lambda. Here is 3.2 lambda. Is 3.5 lambda coming over here? No. Here also the path difference is 3 lambda. Minima is not coming between them. Okay? So here is minima, then here is minima, here is minima, here, 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 and here. So how many minimas are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So minimas are 12 only. Did you understand that? Okay, let's see next question then. Okay, the next question. Suppose our two sources are like this. Okay, and let's assume that the gap between them is 3 lambda. Okay, and here the screen is placed at 1 meter. Alright, so now we know that at this position there is central maximum, 0th maximum. Okay, now in this case also we are trying to find what is the position of first maximum, second maximum, or first minima, second maximum. So suppose here first maximum. After 0, it is first. How many maximas are there possible in this case? 3 lambda is here. So lambda, 2 lambda, 3 lambda, path difference. Maximum path difference is 3 lambda. 1 lambda, 2 lambda, 3 lambda. So 3 maximas. Above as well as below. So 3 plus 3, 6 plus 0th maximum. Total 7 maximas. Okay. So we are trying to find the positions now, first maximum. Now the question first is asked whether this D is very large as compared to lambda. Answer is no. So can we equate sin theta with tan theta in this case? Answer is no. We can't. Okay. So how to solve this then? See, same way, if suppose this is first maxima's position, let's say it's P point, and if we join this point and this point. Okay. And if I say that the path difference will be after we are dropping a perpendicular on this one, and this is the path difference, and I am going to take this as theta, then delta x, you should be remembering it as d sin theta. What is d? 3 lambda. 3 lambda sin. Okay, what are we finding? First maximum. For first maximum, what should be the path difference? Lambda. Put here. lambda equal to 3 lambda sin theta. Lambda gets cancelled. Sin theta equal to 1 by 3. Okay, that much is over. Now, join this middle point with that point. Now, we know that this is also theta. I'm not trying to prove it, we have done it already. So, I'm taking directly this as theta. Now, see in this triangle, if I take this as y, then tan theta is equal to y by this, which is 1 meter. So, tan theta is equal to y by 1. Sin theta is 1 by 3. Tan theta I can find. What will be tan theta? Tan theta will be 1 by root over 3 square minus 1 square. Now, how this is coming? Make a triangle immediately and see. Sin theta is 1 by 3. That means this is 1 and this is 3. So, how this will come? Root over 3 square minus 1 square. That means root 8. So, tan theta value is coming 1 by root 8. We'll keep it over here. This is 1 by root 8 equal to y by 1. So, what is y value? Y is 1 by root 8 meter. From where? From central maximum. Okay, if suppose I am asked find the position of second maximum, then what I will do? I will keep here delta x as 2 lambda. If the question is asked find first minimum, then what I will do? Delta x I will keep lambda by 2. Second minimum, 3 lambda by 2. So this is how the questions are asked, but remember in this case, this value still is comparable to lambda. That's why I am not directly equating sin theta with tan theta. Okay, that's all for now.